Well, we've got a Hobbyking Bixler here, and I had a bit of an issue with it. I was flying it by the lake, which is a saltwater lake, and my son launched it. There was a gust of wind. It went off to the right and landed in the water. And then to make matters worse, I picked it up and turned it upside down to tip the water out of it. I should have remembered there's a vent in the front of it. I should have let the water out there. But anyway, tipping it upside down, got water in the motor. Well, I let the thing dry out for a couple of days, and then I thought, well, give it a try. So I fired it up, and this is what happened. There's 1 lead of the motor, minus any insulation on it. There's the remainder of it there, just absolutely fried. Fried it right through the fuselage, cut a nice channel through the middle of the fuselage where the wire was. So anyway, then I go to look for this motor, and they're no longer available. They're not building them. So I thought, what do I do? So I got online. I see that there's a lot of you out there that maybe bought one of these things as a RTF where the motor wasn't included, and then realized, what on earth do I do for a motor? So I did a bit of a search and came up with one that I think might work. It's going to take a fair bit of modification, but it's a Anoel, A-N-O-E-L, brushless motor. Looks to me like it's got about, let's see, 3, 6, 9, 12 coils. Not sure about the number of poles. I could probably look that up. But this one is a D2822 1450 kV. Okay. It's a tiny bit bigger than the original. I measured to make sure that it was going to fit in the hole. But as I look at it now, thinking about that fit, I'm thinking there's not a lot of room for that cooling air to get past it. And that's assuming I get it in there right. And then, of course, we got these wires coming out the side, which is very common for these little brushless motors. And, you know, I might be able to force those to go back, but to get into the holes that would be, you know, right back here, I don't think we're going to do that. So I've decided to cut a hole in the top, and I'm going to run the wires through the hole and then back in through the air vent there. So that should work for that. But now the next thing is I'd like to give myself a little bit more clearance in there. And by the way, I kind of messed this up a bit in that I was thinking that I wasn't able to get at the screws on the back there. They're Phillips head screws, and you can't get a screwdriver straight on it. It was feeling like they weren't moving. And so I went ahead and I actually cut out the whole motor mount and removed it all that way. So that messed up the foam a little bit here. And then discovered that the screws were just simply so loose that it felt like nothing was happening when in actual fact it probably was. So if you need to take one of these out, there's just 2 screws in there. They're Phillips head. You get at them through from back here. You need a nice long screwdriver to get as square onto them as you can, but they're probably not going to be as tight as they should have been anyway. And why they didn't use some sort of hex type socket thing, I don't know. But anyway, we're going to give a try to get this in there. And what I'm going to do to give myself a bit extra room, this is a total experiment. I've never done this before, but I got this wood burner thing. And I'm going to heat it up, and I'm going to just try tapping it on there and just see if I can just coax that thing a little bit wider. I'll scribe a circle on there first to give me a little bit of an indication as to how I'm going, and just see if I can do that to give myself a little bit more air clearance. So let's see whether this works. It's very interesting here, but I found this little end piece that goes into a tube, and it just happens to fit nice and snug right inside there. And so I use that to scribe the hole around. How do you like that for coincidence? You never know when you save these things what's going to happen. Okay, so that gives me something to judge by to try and keep it somewhat equal. We'll see what's happening with this. I'm not going to stick my finger on it. Yeah, I thought that might do something. So I'm just melding it just a little by little. I felt this would be better than trying to cut it. By the way, I might mention with that motor, it does have a slightly larger shaft than the original one, but it does come with a little spinner prop attachment device there. This wood burner I bought online, one of the Chinese outfits. It was extremely cheap. I got it, original purpose was to help with covering where you want to sort of burn off some of the covering in certain joints. But hey, you can always come up with new uses for different things. It seems that padding it seems to give a better result than trying to slide it. It'll be interesting how to finish off the edge. Try and get it reasonably good looking. Okay, a bit rough looking, but nonetheless, I think that's going to do the job, and now we got tons of room for this motor. I had another thought with regard to cleaning this up, and that is, why not a Dremel motor tool? Okay, so I'm using it at about mid-speed, about a 4 or 5. And I'm just very lightly touching it. Yeah, I reckon that's reasonably good. You could even try that, I guess, instead of the wood burning. It's still going to be a reasonably rough finish, but inside there we don't really care. It's just outside we'd like to have it looking a little bit nicer. So I think that's going to do pretty well. Lots of airspace around it. And just looking at it, yeah, we got the 4 big holes there for these 4 holes, 4 air holes on the back. This particular motor comes with 2 screws in closer and 2 screw holes farther apart. As I mentioned before, it was only attached with 2, and it looks like the closer in ones are the ones that will fit with this. So with the wires coming up this way, it's going to be the holes up in this corner and that corner that we'll be using. And I think that's going to do the job. So we've already put our hole in the top there. Put your wires through one at a time because the connector is the biggest part that has to go through. Okay, so that goes through fine like that. And that is going to be very nice. Lots of room around it. So no problem there as far as cooling goes. The pusher prop, it is an interesting thought as to how it goes about circulating air. Air is coming in there, it's coming in the back of the motor, and I guess spitting it out on this side, and a little bit on the outside bits there that'll come past this part of the motor and help cool that. We're now getting ready to mount the motor in our Bixler. That's the original one here. This is our replacement, and as I've mentioned before, this is a D2822 1450 kV. It's a ANOEL, ANOEL is the brand. brushless motor, G-Power series, made in China, of course. You can see the case is a little bit shorter than the other one, which generally means a little bit less power, but more diameter and more poles in it, which is a little bit greater power. Shaft is bigger, but fortunately they give us the adapter for the prop along with the motor. So we're going to be in good shape. We got an M3 bolt that was in the old one, and we're going to use M3 in the new one as well. Just double check that actually was M3. Yeah. So M3 in the old one, M3 in the new one. With my M3 bolts, the smallest that I have is this one here, which is almost well, 7.5 mils in length. And of course you have to be careful because that bolt is going to go in there. You don't want it to be hitting on these coils in there at all. And that would probably work, but I'm going to make it something closer to what the other one used to be, so I can take a fair bit off of that. The old one is 5 mil, so I might go about 6 mil, let's say. And so what I'm going to do is I'm going to put a nut onto the end of the bolt. For 6 mil, it's going to be, see, 6 mil. The nut is a smidgen over 2. That's not taking much. So I'm going to take about 1 blade width of the grinder off of the end of that, and then I'll clean it up with the file. And then we'll screw off the nut, which will help clear the threads to make it a little bit easier for it to thread into the motor when I put it in there. So that's what we'll do now. Okay, we've got our bolts cut. They're just a millismidge, very precise engineering term, millismidge longer than the original one. I'd say just under a millimeter longer. I've had a look as far as threading them into the motor, and it looks to me like they're going to clear. And I note that because this is an outrunner, the coils don't spin, they stay fixed. So it's just a matter of this being clear of them when it's threaded in, and that's definitely going to be clear. It could go all the way in there. Yeah, it can go all the way in there and stay clear, and it's got the plastic bit that's going to get fastened in there. And at this point here is where it's fully threaded, and that's thicker, I think, allowance there for what that plastic is. So that's a good length. I've got them both the same length, so they're identical that way. I might mention, you know, I had the nut on it when I clamped it in the vise. I made sure that in the vise it was horizontal, so I put it in the side of the vise. Had it clamped with a nut on it, and with this tightened onto the nut, I then used a thin bladed grinding wheel to cut it off. Then I used a file to get the end of it totally flat, so all cleaned up that way. And then I took the file going around the edges of it very lightly to just chamfer off a tiny bit of the edge, and then threaded off the nut to clear out the threads, and they work beautifully. With these, we generally don't use the thread locker, in that it can be hard to get them out, and with it against plastic, that should compress the plastic enough to help hold it there. So we're counting on that. Now the next bit is we got to get the nuts in through this hole here into the thing. Fortunately we can see well from this side, But our problem is that our driver is a little bit sloppy, and it's not going to do a very good job of holding the bolt to where we want it. So you could do a variety of different things. It might be that blue tack would do the job. But what I'm going to do is I'm going to put a tiny bit of sticky tape onto the end of the driver, and I'm going to have the sticky side towards the driver so that hopefully it'll come out when I pull it out. And I'm just going to shove this thing into there, which holds that nice and securely. So now I can point it any direction that I want. And I'm going to get it into the hole, so position it from out here, but I'm going to be looking from this side to get it into the hole. And it looks like it can just hold threads a little bit in the hole. So I got that one in the hole. That came off. That's what I wanted. I'll then get it onto the next one and get it into the hole. So we're using the top one and the bottom one across from each other. And the other good thing about using a hex socket in the end of the bolt is that you can get a ball driver such as this, where on the end of that, you probably can't see that too well, but on the end of that it's got a bit of a ball shape to where it allows it to be at an angle and still turn to go in. So with something like this, that is quite an advantage to have it that way. Okay, the top one is just sticking through a tiny bit. I think I'll get both of those in a little bit farther. It's actually easier to see it from this side, but we have to drive it from the other side. Okay, so now I'm going to get my motor in there. Do one lead at a time up through the hole. Okay, those are all up through there nicely. And now hopefully you're going to just want to naturally line up. This thing is forcing it to be in the right direction, and now I do need to look in this way, and that one's nice and snug. Okay, so our motor is in place. Lots of room around it, more than it's really needed, but hey, it's not going to do any harm. We've got our thing for the prop spinner. Here's the prop. I imagine we're going to have to drill out the shaft a bit. Oh, it looks big here. Okay, that's obviously the right size, and yeah, it looks like we got a proper size shaft for that prop. Yeah, precise. That looks very good. That will go on there. Okay, got an issue. Apparently I've got it at a little bit different angle, probably when I glued in that thing. Sure looks pretty flat. And I wonder if I can put it out a little bit. Will that make a difference? Okay, so I can either cut a bit of a clearance there, which is going to create a stress point, or I can space out the bottom of the motor. See, this one was longer. Could space the whole motor out farther. Yeah, we could do that. Wonder how far we need to be. This one sure looks to me like they're about the same as far as the distance out, so something is different in terms of the angle of that mounting plate in there. So I guess I just use some washers to bring it out, or I could use this to bring it out. Cut off the tabs. That's probably not going to be enough. Could reduce the prop. Right now with the 2 screws on a flat plate, it holds it flat on the plate. If I put washers behind those 2 screws, then they got the potential for a vibration happening this way, which we don't want. So ideally we would do something like this that affects the whole thing. Yeah, this is one of those things that you don't figure that you're going to have to do, and as things develop, you adjust accordingly. I suppose it's possible too that I've got this plastic mounting thing farther in than what it was originally. And certainly having these screws, hex driven screws, is way better than what was in there with those Phillips head screws. It would be nice to have ones that aren't black. Maybe I need to paint the end of them. Okay. How do I feel? The top ones are really hard to see and a bit hard to get at, but there I'm on it. Okay. Oh, that's that. Good to have a magnetic something or other to grab them when you need to. Well, just another thought. I could have these. Could use these as spacers, so put these in that way and have the other ones come from the back. Okay, let's go ahead and do both. Okay, what I'm going to do, just thinking about it, when I have the 2 batteries up there, I'm nose heavy. When I have the 1 battery up there, I'm nose light. But let's say I stick with 2 batteries, so I'm nose heavy, so moving the motor farther back here is going to be good, plus whatever weight these things have. So I'm going to have these 2 screws that I've ground down. I'm going to have those in 2 of the holes, and then I'm going to have 2 longer screws going through from the front through this way into those 2 holes. It will have this back plate here compressed against those 2 screws, and I'll have tension on these 2 screws, and that's going to hold it all square and help avoid vibration one side to the other. That's the plan. You've heard me say that before. Well, are we having fun yet? I actually enjoy this type of problem solving and working through these things. Okay, we've cut off the outside part of the tabs on this. We take note that these holes, you got 2 that are closer together and 2 that are farther apart. So we need to have a look and see how it's going to go. And we note that you got 2 closer together, 2 farther apart. And the closer together ones are going to be there and there. Okay, so it's going to be kind of that way. It's got chamfered holes, and I think what I want to do is, since this is going to be holding it off, I want to put these, the short ones in there, in those 2. And those are just going to be sandwiched between the motor. And then this one is going to come through the plastic from the back, screw into the motor. And I've noted how long it is, just to make sure it's not going to go too far. So this is the bolt that's uncut. And I compare that with the one that's going to be holding it off, and I can see I got just enough to nicely get through the back of that motor. Okay, so that's going to be fine. So the next thing I'm going to do is put these long ones in the spots where they go. So we got to do our magic with the tape again. So the sticky part of the tape against the tool. Poke it into the hex of the bolt. Get it into the hole. Okay, we're going to run it in a fair ways to make sure we can get that plate on there. Okay, that should do it. And our second one is a long bolt. Get it to where it's going to stay on. Get where we can see where it's going. It's coming through nicely. Okay, so this, actually it's not going to quite work that way in that there's not a hole in the precise position where that is. So I'm going to have to grind these off farther because there's no, the holes that are there are in closer as in these two. Got 4 holes, they're all the same. So this can't be sticking out on the back. It's got to hit against plastic for at least part of it. I think I'll try and grind them off. We'll see what we can do with that. Be nice if I could hold it on there and just grind them flush. I'm going to want to clamp it down and then use the grinder to grind it flush without taking my fingers off. That's the challenge. Okay, back with you in a tick. Just to let you know, the grind off your fingers idea didn't work out too well. Don't worry, I didn't grind off my fingers. I just couldn't hold them steady enough to get the grinder to really get a hold of it. So what I did instead is I clamped them in the side of the vise to where the bolt is sticking out to the side. I just ground it down and then kept occasionally putting the plate on there to see whether they were sticking out at all. And I got them down far enough to where they're either even with a plate or slightly indented. So now the next thing I'm going to do is just to help me to hold things in place. I'm going to use some CA to just glue them in their places so they don't need to come off or anything like that. And these are the ones in the outside positions and with a chamfer on the opposite side. And I got some CA there. I'm going to do this without gluing my finger on as well. This is medium CA that I'm using. Okay, as I was sighting down sideways on this little bracket, just by eyeball, I could tell that this one nut thingy was just a little bit crooked. So what I did is I quickly took it over to the vise, just put it into the vise and clamped it into the vise with both of those, and it actually straightened that thing out. So I imagine probably this medium CA hadn't totally hardened yet, and it allowed it to squeeze in there a little bit farther. There might have been a little bit of burr of aluminium or something like that from when I was filing or clamping before that was holding it up, but that now looks a lot better. So this is going to hold that off like so, and these other bolts. So these ones are going to come through that plastic bit in the back and into the motor, and it'll be something like that. Okay, so let's put this on there. A variety of tools are handy to put things in place. Needle nose pliers, what are the surgical type things? Forceps, is that what that is? I think so. Something like that. Okay, so that's going to go in there onto those 2 bolts. Okay. And we're going to put the motor in on top of all of that. I just went straight in there. We'll see if we can get the bottom one in. Okay, that's got it. Okay, those are both nice and snug in there. Okay, now, what about a prop? Just the tiniest bit. Okay, I think I'll trim the prop. I don't want to create a stress riser right there. Okay, I'm starting out with 2 mils. We'll start out by just trying to do something similar on both sides, and then we'll use the balancer to make sure it's okay, and continue to adjust as necessary. We trimmed off the points off the end of the prop, and in doing that, we put it on there and we kept trimming until when we turned it, it was just barely brushing on this, and then we kept sanding it a little bit more as such that as we turned it and pushed down on this, it just barely touched. And now, as it is now, it doesn't touch at all, but it's just barely clearing that thing. Now this is a prop balancer. It just fits onto the prop, and you use your fingers to twist it. There are ones that are more precise. This one has a little tiny bit of friction. You know, it's generally made for larger props. But if you can get it to swing backwards, it's obviously pretty good. But here a minute ago, I was able to get it on my fingers in such a way that I could flick it up. Yeah, there it just went backwards just a little bit. I flick it up just a tiny bit and then it comes back down. Okay, for it to do that, that's saying that this end is a tiny bit heavier than the other end. So I'll just sand it a little bit. You can get much more precise ones that have a better way of supporting it. This one is quite practical for heavier props. This thing being so light, any tiny bit of friction on these points makes a big difference. I would say this end is still a little bit heavy. I don't think that's going to cause any problem. When we get it going, if it feels like it's vibrating, then we'll give it some more attention. But at this point in time, I think it's quite all right. Now look at my 2 mandrels here, so picking out the one that's the right diameter. Get the prop on there. And it had the one with a skinnier bit on it. Actually, the prop goes the other way. It's got a bit of the side that's pushing on the wind has got a bit of a cup shape, keeping in mind that this is an airfoil that's going through the air. So it's got that little bit of a curve on the top, and you know, the bottom is going in, so that's meant to go that way. Okay, so we're going to put it on there. I'm going to put it on not quite all of the way, just to give us a little bit more clearance. Snug that up. Verify it's missing, barely. Not missing by much, that's for sure. Okay, and then we need a little something to tighten that guy down. Okay, so that's missing the thing there, and we'll see how that goes. Well, that's got the motor all set up and going on the Bixler, so we're well underway. And next we've got to move into the electronics, getting in the ESC and the receiver, getting the antennas positioned. Going to give more attention this time to keeping those antennas perpendicular to each other. So that'll be on the next video. And I might mention on this video, if I was doing it all again, I'd make a couple of changes. And part of the reason for showing you these things is we're allowing me to make the mistakes so that you can learn and do something better. But for example, with regard to the motor, going through all of that effort to try and get it moved back and all, I don't know that that was needed. I had to trim the prop off anyway, so a couple more millimeters off on the prop and it could have stayed where it was. And of course the motor mount, having pulled that out, you know, with what we know now, I could have just left it in there and easily could have got the motor out. So anyway, a lot of those things you'll learn so that you can do better. And in the meantime, we'll continue to sort of plow the way ahead so that you can see some of the potential things that you might want to do a little bit different along the way. But all in all, it'll be a good result. So if you haven't done so already, be sure and subscribe. That little circle to the right allows you to click there. It doesn't cost you anything, and keep all of these things handy. And then have a look at some of the other videos that we've got on our channel. Well, you have a great day and happy flying.